We have finished the construction of the experiment section, and now we move into Part C, cohesion and transition techniques. I'm going to introduce the essential techniques needed to polish your writing. An effective experiment section must use clear signposting, consistent terminology, logical process order, justification transitions, and frequent referencing to figures in prior sections. These elements all work together to guide readers smoothly through the experimental design. The coherence of your argument is as important as the rigor of your data. We will look at the first two techniques. The first is 1. Signposting with section references. This is simply using explicit references like as discussed above in section 3.1 and using the metrics described in section 4.3. These phrases are non-negotiable for structural clarity. The second technique is 2. Topic sentence framing. Every subsection must begin with a sentence that establishes the topic. The key is to write a sentence, like, we used a collection of 30,000 QA pairs for training, that both previews the content and immediately anchors readers to the topic of a new paragraph. This technique improves the overall scannability of your paper. The third technique is 3. Logical sequencing. The sequential order is the map. Training data must come first, followed by systems compared, then metrics, and then the evaluation data. This must mirror your algorithm. The fourth technique, 4. Referential consistency, ensures clarity. You must reuse key nouns consistently, using tritus or evaluation queries every time, because avoiding unnecessary synonyms enhances clarity for readers. The fifth technique is 5. Transitional phrases for justification. These phrases, such as therefore for cause or however for contrast, help readers understand the reasoning, not just the procedures. This is how you justify your methodological choices. The sixth technique is 6. Scope-defining moves. This is essential for sharpening coherence because you must clarify what is included and excluded. For example, saying, we focus on 4 question types tells the reader the limit, while saying, we did not use tuning data for evaluation tells them what was excluded. The seventh technique is 7. Summarizing or previewing transitions. You should preview upcoming structure to help readers navigate the text, using phrases like, in this section, we first describe, then, finally. This is a powerful roadmap. The 8th and final technique is 8. Visual anchoring. You must refer to tables and figures to support smooth transitions and tie explanation to visual evidence. Using phrases like Table 6 gives the distribution or Figure 4 shows an example. We now transition to Part E of our lecture, focusing on presenting numbers. The core principle here is that every number you present must be both relevant and correctly formatted to avoid misleading the reader. We must first look at categorical data, where the recommendation is to use frequencies and percentages and always report the denominator, which is the total number of observations. For continuous data, the choice between mean and SD for normal or median and IQR for skewed is crucial. A simple rule applies to all data. You must always state the sample size that was used. Furthermore, you must avoid spurious precision. Don't show unnecessary decimal places that imply false accuracy. You should use greater precision only if the measure will be used in further calculations or analytical results. Presenting tables is equally important. The foundational principle in doing so is simple. Maximize clarity by minimizing clutter. The general principle, which is Tufts' rule, is to maximize the information-to-ink ratio, which means you should include as much information as possible without losing legibility. This principle dictates the design. For the use of lines, you should use solid lines sparingly, which means only to separate labels or summary rows. You must avoid vertical grid lines when possible. Instead of lines, you should use white space to separate data groups. You must also ensure table labeling is clear. Each table should have clear row and column headings and a brief summary. Finally, for column versus row arrangement, place similar information in columns because readers scan columns more easily than across rows. Let's see the practical application of Tufts' rule in troubleshooting our ALG paper. I must admit that although I often use ALG as our model paper, there is some room for improvement in its charts and figures. Look at the two tables on the slide, both showing Table 6, the number of training questions for each question type. The table on the left is the bad version, which uses heavy vertical and horizontal lines, which creates a dense, boxed-in look. This violates the information-to-ink ratio. The table on the right is the good version. It has minimal lines, just 3 horizontal rulers, and avoids all vertical grid lines. Notice how the white space is used to separate the data and the question types, which drastically improves legibility. Furthermore, the headings have been shortened from question-answer pairs and collection to a concise QA pairs. The entire right table feels lighter, more professional, and focuses the reader's eye entirely on the data. The goal of this comparison is to isolate the elements that make the right table journal quality. The right table is definitively superior because it improves legibility and consistency. For borders, the right table uses minimal grid lines, which follows Tufts' principle, while the left table's solid lines create clutter. This affects density, where the right table's white space gives it a clean, open layout. Regarding headings, the right table uses short and clear labels like QA pairs, making it concise, unlike the left table's long, 2-line headings. Pay attention to font style. The right table uses italicized, no quotation marks, which is typographic consistent, while the left table is inconsistent. Most importantly, the numbers in the right table are right-aligned and evenly spaced, which is crucial because it allows comparing numbers vertically. The right table achieves 6 key results. It reduces ink load, which gives a higher data-to-ink ratio. It improves legibility via white space instead of heavy borders. It shortens labels for conciseness and uses consistent typography by italicizing, not quoting, phrases. Crucially, it lines up vertically, which makes for effective scanning and comparing data. Finally, it groups information visually, not mechanically. The single takeaway is this. The RT table exemplifies effective data presentation by applying Tufts' principle of maximizing clarity, consistency, and readability while minimizing non-informative ink. These details are what make your paper look professional. We conclude our journey on the experiment section by boiling down all the rhetorical and structural techniques into 5 final, actionable steps. These are the 5 things, or takeaways, you must check before submitting your final manuscript. First, you must follow the experimental pipeline, making sure your method section's blueprint matches your experiment's execution. Second, describe data transparently, providing all sources and scales. Third, define systems and conditions clearly, ensuring your comparison is fair. Fourth, justify your evaluation metrics by providing the theoretical and practical reasons for your choices. Fifth, and finally, ensure logical flow and cohesion across the entire section using those strong transition phrases and visual anchors. By completing these 5 tasks, you move from a mere description of your test to a compelling and fully validated empirical proof, which is the gold standard of academic publication. Okay, that's all for this section. Thank you for coming, and see you in the next lecture video series.